Everyone, myself Beslin Babish, currently pursuing ME Manufacturing first year. I'm going to present my mini project on the topic of experimental study on wear behavior of AL-SI10Mg at elevated temperature under the guidance of Professor R. Surendran sir. This is my first review. My objective of the project is to analyze the tribological behavior of 3D printed material AL-SI10Mg and to analyze the particle size of material by scanning electron microscope. Next, I am going to explain about my methodology. My methodology is, first of all, I am going to read the literatures relevant to my topic, and after that, after reading the literature survey, I am going to describe the problem. This step is known as problem description. After problem description, I am going to select the material which is relevant to that problem. This step is known as material selection. After material selection, the material is undergone pre-processing process before the testing of material. This step is known as material pre-processing. After material pre-processing, testing of material is done, which is done in pin-on disk machine. After testing of materials, the values obtained is analyzed through the various softwares like Design Expert software and Fuzzy Demetal software. This step is known as analysis of wear parameters, and after analysis, the conclusion is given. And this part is literature survey. In this, I am going to explain about the conclusions and the authors relevant to my topic. The author name is J. Singh and A. T. Alpas. From their papers, I have got to know the following conclusions, like AL6061 alloy and the particulate reinforcement AL66 AL2O3 composite shows a mild to severe variations in transitions when the surrounding temperature is increased above certain temperature. This transition occurs at higher temperature in the composite. From this, we can able to identify that in higher temperatures the wear rate is less. Like the material shows the wear resistance high in higher elevation temperatures. And the next point is, at elevated temperatures, AL6061 20% of ALO exhibits wear resistance than AL6061. Increasing the load increases the wear rates at a given temperature. In this, the composite material of AL6061 and 20% of ALO exhibits overtakes the AL6061 in wear resistance factor, in which the composite material shows the higher wear resistance property, and by increasing the loads the wear rates can be changed. Like by increasing the loads the wear rates will be high. These are the conclusions I have taken from the J. Singh and A. T. Alpas paper. And next, H.P. Michael Rajan. From that paper, I have got to know the conclusions that the resistance to wear of AMCs, that is aluminum cast materials, was lower at higher temperature for a constant amount of titanium boron particles. The increase of titanium boron particles pushed the transition wear temperature from 180 degrees Celsius to 210 degrees Celsius under the experimental conditions. In this, we have come to know that aluminum cast alloys, when the titanium boron composites is increased in the percentage, the wear temperature increases from 180 to 210. It shows a various deflection. Like in higher temperature, when the titanium boron particulate matters is high in that AMCs, then the wear resistance is high, so that the wear of the material is less in higher elevated temperatures. And from the paper of SMR Mousavi, the following conclusion is obtained. The wear rate of aged 2024 AL alloy and its composite reinforcement with 20% volume of silicon composites achieved the lowest values at 25 and 200 degrees Celsius respectively. Then it is increased with increasing temperature. In this, the aluminum alloy is mixed with the silicon composites. This is the only composites in which the temperature is increased as well as the wear rate is also increased. And in this part of material selection, I am going to describe about my material AL-SI10Mg. The dimensions of my material is 80 into 12 millimeter square. This material is obtained by additive manufacturing, selectively laser powder bed diffusion method. In this method only my material is prepared. It is bought from NIT Trichy. The major applications of my AL-SI10Mg is in housing and ductworks, engine parts, molds for both prototyping and manufacturing purpose. Particularly in engine parts, the piston areas are involved with AL-SI10Mg, and in housing and ductworks also it is used. From these applications, we get to know that daily basis of applications is done by AL-SI10Mg. So the minimum impact in AL-SI10Mg has a maximum outcast in real-time applications. So it is very crucial area in AL-SI10Mg. In testing of machine, I am going to describe about my pin on disk machine. The pin on disk test is undergone in pin on disk machine. ASTM standard number of G99.5 and ISO number of 18535. The trivometers can be used to investigate the friction and wear behavior of material pairings. This pin on disk machine is mainly used for observing the wear behavior of a material. The main advantage of this pin on disk is that variety of materials can be tested. In this pin on disk machine, wear behavior can be tested and variety of materials also can be tested. This is the main advantage of this pin on disk machine. And the only requirement is the specimen is to be made as per the requisite dimensions, and it must withstand the stresses which the pin withstand during the tribot test. In this point, we have get to know that there is some certain dimensional requirements to undergo the test in pin on disk machine. Our material should be cut down into such dimensions in order to undergo our testing in pin on disk machines, and the material should possess withstand the stresses during that wear machining. This is the image of pin on disk machine. The left side part shows the pin on disk machine, and the corner of that shows the load acting area. And in right side part, the digital display is given. The left bottom corner shows the temperature of that material, and the center portion shows the time limit in which the wear happens, and the right corner shows the wear rate. In design software, in this software only we are going to give input as the observed value of pin on disk machines. These inputs should be given in this software, and we will be getting the conclusion from this software. Design software we are going to use is Design Expert software. Similar kind of softwares are there like fuzzy demetal tool and all. The major objective of these softwares is they will expose the relationship between effect and the cause. A slight cause can have a huge impact. That's the main objective of these softwares. They used to give a relationship curve between these two. In Design Expert software, I'm going to say some beneficiaries of Design Expert software, such as Design Expert is a powerful statistical software used for design experiment DOE and analysis of results. It allows users to plan, analyze and interpret experiments efficiently, helping them optimize the product designs and process. In this, variety of values inputs can be given, and we can alter the input values. According to that, we will get output value, which is also known as effect. Some key factors include factorial, response surface. Response surface, in other words, we are known to have that RSM, response surface methodology, and mixture and Takeuchi designs, as well as robust graphical and statistical analysis tools. Now, in this slide, I am going to explain the methodology. RSM, response surface methodology, central composite design methods. Input factors include load, sliding distance, sliding speed, temperature. In this load, we are going to change from 10 Newton to 50 Newton accordingly, and sliding distance and sliding speed are kept constant, like sliding distance as 600 and sliding speed as 1500 RPM. Both the values are optimum because in these values only it shows a higher wear rate. So we have kept this as optimum value and as constant. And temperature, it has minimum of 32, maximum of 300, but in our case we are going to do up to 200 only. We are going to vary the temperature as well as the load. Each 10 experiments we are going to do. The major output or the responses of that pin on disk machines will be coefficient of frictions we will be getting from that machine, and wear rate we can calculate from that. How we can calculate the wear rate is volume by Newton meter. We can get the wear rate, and how we are calculating the time is by calculating the by having the simple formula as speed is equal to distance by time. By having the speed is equal to distance by time, speed we have already known that sliding speed is 1500. First of all, we are going to convert that into velocity pi dn. By using the pi dn formula, we are going to have a velocity, and the distance we are having 600. 600 by velocity will give us the time. The standard time of our project is 7 seconds. This is our design of experiment chart table. In the left corner are standard values that we cannot alter, and the second column tells about the run, how much runs we are going in each sides. In each load we are going to get 10 runs each, according to which the value is going to change and alter. In factor 1, load is given. First of all, we are going to take a load of 10 Newton, and second factor, sliding distance is given, that is for us it is constant, and third factor is sliding speed, that is also for us constant, and fourth factor tells about the temperature. We are going to vary the temperature according to the load parameter is given. We are going to change the temperature by 35, 60, 90, 120, 150, 180, 210, 240, 270 and 300. And what are the outputs we are getting is response 1 as coefficient of friction and response 2 as wear rate. In terms of unit is millimeter cube per Newton meter. And the procedures for my experiment is: step 1, we need to set the speed of the disk as optimum, that is 600 rpm. We have mentioned that rpm is our optimum speed. And in step 2, we have to calculate the time from the sliding distance and the set time. We have known the distance and we have already known about the rpm. From rpm we need to calculate the velocity using Pydian formula. From that we can easily calculate the time. The standard time is 7 minutes 57 seconds. And in step 3, fix the testing material in the pin on disk machine and change the temperature accordingly. First of all, we need to check the temperature as 30, and we need to set the temperature as 30. We need to alter up to 300. And in step 4, we need to apply the load as from the 10 to 50 Newton we can alter. And in step 5, we need to start to run as well as in monitor as well as in analog form, and repeat the experiments for various combinations of loads, temperature in design of experiments given by the design expert software, and note the output responses. By giving these inputs parameters in that software, we will be getting a graphical output from which we can correlate the relationship between the wear rate at elevated temperature. The major impact factor of my project is the ALSI10MG can be made in two different ways. One is additive manufacturing way, that is laser powder metal diffusion method. Another one is through casting. We are using ALSI10MG through casting in piston areas and day-to-day real life applications. By using this additive manufacturing material, how much it differs from later part to this part, that is my objective of this project. Thank you.